Alrighty, well here are the first basics of what a normal curve is. And what it is, as you can see here from the sketch, is it's a perfectly symmetric curve here that is unimodal. And basically what happens here is we have the dead center of this curve. Go ahead and draw a line straight down here. Here's dead center. And this is the median of the data, or you could look at it as also the mean. Anytime it's perfectly symmetric, it's also the mean. And as it turns out, anytime you have what we call a normal curve that's perfectly symmetric and unimodal, there are some things that are true about it. And these things are, it follows the 68, 95, and 99.7 rule. So what that means is that 68% of all values lie within a standard deviation of the mean. So in other words, if the middle is the mean, and it is, I'm going to go ahead and put the mean right here, what would happen is this would be one standard deviation higher, and this would be one standard deviation lower. And so basically about 68% of our curve would lie in this range right here. Also, 95% of all values would lie within two standard deviations. So once again, here's another standard deviation in the negative direction here, and this is positive 2 standard deviations. So therefore, 95% of our values would lie within 2 standard deviations of the mean. And finally, 99.7% of all values lie within 3 standard deviations. So 3 standard deviations would be out here. And that would be nearly all the values. And a lot of things in life kind of take this shape. It could be, things like weights of people or heights or all sorts of different natural phenomena take this look of what we call a normal curve. And this phenomena is true. So as long as it's normal, symmetric, unimodal, this would be true of that curve. And the other thing to know is that we've been dealing so far with what we call real data, where we've taken actual measurements of ourselves or asked questions, and it could be about a class or maybe even a school. It's things we observe or know. We've made histograms and computed stats like means and standard deviations. Well, in life, there's things that we want to know about, but are in a sense unknowable. And what we call that is we call that a model. So these things that are unknowable, we call these parameters and so forth there. So it might be, maybe I want to know the height of all people in the United States. Now, I suppose in a sense I could go out and measure everybody in the United States, but that would be very difficult to do. It could take years. I'd miss people. People would grow in the time possibly between when I measured them and when I measured other people. So it's this whole sense of wanting to know about everyone, and that's not really true where in a class I could do that, but I couldn't really do this in real life. And so what we do is we now call the center something different. It's no longer x bar, it's this Greek symbol, and it's mu is how we say it. And the spread is no longer seen as being s, as being, theoretically, we call it sigma. This is lowercase sigma over here. And so normal curves have a center of mu and a spread of sigma. So if we went back to the curve back here, simply what would happen is it would be the exact same thing in terms of the rule. However, the middle is no longer x bar, it would be mu. This would be plus 1 sigma. This would be minus 1 sigma. This would be minus 2 sigma, and this would be plus 2 sigma. And finally over here, this would be minus 3 sigma, and this would be plus 3 sigma. And so typically in our class, it's nice if you can do an actual distribution and get data on a class or a school kind of a thing, but generally we're talking about a model for all people, for all things, and in that case we're going to use mu and sigma instead. So let me show you how this would work with actual numbers. Take, for instance, we have IQ scores, and if you went to a website and asked and found out about IQ scores, they would tell you that it has a mean of 100. This is a mean right here, and a standard deviation of 15. Once again, how we can write that as a shortcut, normal is with a capital N here, so we say N, capital N, and this is what we would call, once again, our mu, and this is what we would call our sigma. So as it turns out, following this model here, 68% of scores are within a standard deviation of that. So basically all you have to do is, what's 100 minus 15? Well, 100 minus 15 would be 85, and 100 plus 15 would be 115. So it turns out that basically 68% of people are between an IQ of 85 and 115. Likewise, if we were to go ahead and do 95%, that's within 2 standard deviations. Well, 2 standard deviations is 30. 2 times 15 is 30. So if you subtract 30, you get 70. And if you add 30, you get 130. So, 95%, that's a lot of people are in this range here. And finally, the last one over here, if we multiply this by 3, we get 45. And if you take 100 and add or subtract 45, you would get 55. And then you get 145. So nearly all people, 99.7% of people, have an IQ between 55 and 145. So if you were either below that, below 55, or higher than 145, that would be very weird and strange. So this allows us to answer some questions. Things like, well, what percent of IQs are higher than 115? Well, if you notice here, 115 was one of our numbers. So if I were to draw a little sketch of that right here, of a normal curve, we know this, that if I had 85 right here and I had 115 over here, we know that in the middle between this here, this is 68% of all values. Now, because it's perfectly symmetrical, what percent is not accounted for? Well, if we take 100 minus 68, that means 32% of our curve is unaccounted for, which means in these two tails, on the low tail and the high tail, it's going to split that 32 in half. So basically there's 16% should be over here and 16% should be over here. So when it says what percent of IQ scores are higher than 115, well, the answer would be 16%. What if I said instead what percent of IQ scores are lower than 70? Well, once again, let's just draw a little picture over here. If I were to draw a little sketch, once again, of a normal curve, it's not the best picture, but it'll work there. Here's my normal curve. Here's 70. Here is 130 out here. And earlier we said 95% of scores are between 70 and 130. So that means 95% are in between these two values here. And of course, if you took 100 minus 95, you would get 5, which means we have 2.5% above 130 or higher, and we also have 2.5% over here. So what percent would be lower than 70? 2.5%. So that is your first basic primer on normal curves.